Hi, today we are having one interesting question. There is only 2-line program and we have to find out the output of this. In the first line, there is int a equal to -2. The initial value of a is -2 and the same value has been printed in the form of hexadecimal number. But we are having these options, 4 options, but we have to convert or transfer the value from -2 to the form of hexadecimal. We know always that any negative number, when it is stored in the computer, always is stored in the 2's complement form. So the first step, what we have to do, we have to convert into the 2's complement form, and then after, in the second step, this 2's complement value we have to convert to in hexadecimal format. So the result will be printed accordingly. Okay, let's come to the example of the 2's complement form, how we are coming to the 2's complement form. The entire operation I have shown you in using the 16-bit register, right? So this is the 2, this is the binary representation of 2, fine. And now we are converting into the 1's complement. 1's complement means 1 replaced by 0 and 0 replaced by 1. So this is the 1's complement. Now if we add 1 with the 1's complement, then we are coming down to the 2's complement. So the 2's complement is 1 1 1 1, 1 1 1 1, 1 1 1 1 and 1 1 1 0. Fine. So if this 2's complement, if you convert into the hexadecimal form, then it is coming FFFE. But all these operations we did on 16-bit register. If you do it on the 32-bit register, then what is happening? The value would be FFFF and FFFE, right? Okay, let's run the program and we'll check it out. What the value the compiler is showing. This is the first line, and in the first line it is showing this long int a equal to -2, fine, and this is the another value printf in a hexadecimal form. Very good, the result has come now. The result is showing FFFF and FFFE. Okay, now we are coming down to our options. What options we are having? As per the options and answer given, answer B is correct.